Let's now come to the main theme of the evening, and it's such a pleasure for me to welcome our extraordinary guest, the great Yo-Yo Ma, a superb artist and a very engaged citizen of the world. Welcome, Yo-Yo.
Thank you. Fabiola.
Yo-Yo.
I was just taught that it's not Fabiola, it's Fabiola. So from now on, it's Fabiola. Can you all say Fabiola? Perfect. From now on, your name will be perfectly pronounced by everybody, at least in this room. So the first thing I want to say, you took me on a visit to the Science Gateway. I saw people kicking protons on
try to mash them.
You know, and taking subatomic particles and moving them into different columns. And then seeing that there was actually an accelerator, you know, an actual linear accelerator with where you could actually see the beam.
Thanks so much for the publicity, Yo-Yo. Thank
That's
you.
my job. Thank you very
thanks
much.
A lot.
Good night.
Goodbye.
Au revoir. Merci bien.
Mission accomplished.
Yeah, okay, fine.
Okay, so first of all, thanks so much for the immense gift of being with us tonight, of co-hosting this conversation. We are going to talk about physics and music. Don't laugh because it's serious. One of the things, you know, we are discussing, we're going to talk about the relation between science and arts and music and physics. And of course, music is based on physics, harmony, and the fundamental laws of nature, as we will see later on, are based on principle of symmetry, so an aesthetical principle. So nature has put beauty and symmetry, we'll discuss then also symmetry violation, at the heart, at the core of the most fundamental law. And actually the current art exhibition in the Science Gateway, in the half of the smaller of the two tubes, is precisely about one of the topics that we are going to discuss tonight, exploring the unknown. So should I start with physics, Yo-Yo?
I think you really should.
We know today that the matter, the ordinary matter of which we are all made, is composed of atoms. Atoms are made of a central nucleus surrounded by a cloud of electrons. Nucleus are made of protons and neutrons are made of smaller particles called the quarks. And as far as we know today, electrons and quarks are elementary particles. They cannot be cut into smaller pieces, and they are the fundamental constituents of atoms, and so of the all of visible universe. Planets, plants, animals, all the objects in this room, all of us, we are all made of electrons and quarks, even Yo-Yo. His electrons and quarks are particularly harmonious, they are special, admittedly, but...
She thinks I'm just a little more quirky.
I didn't say that. Anyway, so at CERN, we study matter at the level of its fundamental constituents, the quarks. And we do so with the Large Hadron Collider, which is the most powerful accelerator ever built by men and women. The energy of the collision can transform itself into new particles. You remember Einstein, E = mc squared.
Which means that?
Energy and matter are the same form, are different form of the same quantity.
Which means that you can never destroy?
Or create energy, yes.
Matter, so that if you...
Matter,
right?
Energy.
So,
energy.
Okay.
So, he's trying to show that he knows physics, but...
I barely know. She talks so fast, I can't understand.
He tries to show that he knows physics better than me.
No, what's kind of interesting...
I'm not trying to play the cello better than you, sorry.
No, I'm not. I just wanted to...
It doesn't start well, this evening, Yo-Yo, sorry.
No. What I'm trying to establish is this. I think I'd like to do an experiment, if you don't mind. I'd like to do an experiment with Fabiola. Would you like to see an experiment with Fabiola? Yeah, okay, all right, so good, ha-ha. Yes, not only was she a philosopher, she tells me I actually studied piano at the Milan Conservatory. I said, you did? That's great, let's play something. Says, oh, no, I've never played with anybody. I said, great, let me be the first person. You know what she said? She says, there are no pianos in Switzerland.
I try to find an excuse, a noble excuse.
There is a piano in Switzerland. I just thought that we could play this structure, a rondo structure, which is basically a nice tune.
So you want to play alone or with me?
No. I just want to play.
He went his way.
I just want to play it fast, so
okay,
that
because I'm slow. Okay.
No, so we can play it together.
You tell me when I can do something.
You start.
Okay. We know today that the universe began 13.8 billion years ago, following a big explosion called the Big Bang. Again, this is scientifically not super rigorous, but okay. At the beginning, it was very hot and dense and was filled with a gas of free elementary particles. And then with time, it expanded and cooled down. And the particles, the elementary particles, combined together, first quarks to form neutrons and protons, then neutrons and protons to form nuclei, nuclei with electrons to form atoms, and so on and so forth, giving birth to the macrostructure that we see today: stars, planets, galaxies, human beings. The Large Hadron Colliders allow us to go back in time up to a millionth of a second after the Big Bang. 10 to the minus 12 second after the Big Bang, a picosecond after the Big Bang. What does it mean? It means that the energy of the collision of two protons corresponds to the temperature the universe had a millionth of a second after the Big Bang. And this temperature, it's quite cold here today, but it corresponds to 100,000 billion times the temperature in this cold. Like music, physics is based on beauty, simplicity, and symmetry. Pretty much like in music, very complex melodies arise from the combination of just 7 notes. The complexity we observe in nature builds upon a very simple underlying structure at the most fundamental level. These are the elementary particles that we know today. So these are the particles that cannot be cut into smaller pieces. And the matter that makes up the whole universe, including us, is made only of the particles on the first column on the left side. Up quarks, down quarks, and electrons. Just 3 building blocks, just 3 notes.
You know what's funny? That its music is also very simple. You start with a note, and if you play another note, it could be a stepwise motion, or going up or down. It could also skip. And it could also, the only other choice is that it could repeat. I mean, those are your choices. Yes, you can have silence, which is definitely an option, right?
Yes.
But those are your choices. So, and from that simplicity of 3 things, you can build a universe, just like we can do with 0 and 1. We're now looking at the thing that you are most interested in, which is dark matter, right? Are you going to talk about dark matter?
Ah, yes, true.
Yeah.
Thank you.
I mean, it's like...
So you see here a beautiful image of the sky taken by the James Webb Space Telescope. And what is, of course, fascinating for all of us are the luminous objects. You see stars, galaxies, etc. But actually, for us physicists, what is the most fascinating is the dark. 95% of the universe is dark. When we look at the sky at night and we see the nice stars and galaxies, what we are seeing out there is only 5% of the universe. The rest, 95%, is a question mark.
And I think what we're going to play in this first movement, for us, is something about the most personal, the most private, the most longing, the things that we kind of want to hold on to. Let's hear it.
see beautiful images of the LHC accelerator and detectors. They are complex, they are big, and they're also extremely precise. They have been built to be functional, not to be particularly beautiful, but actually they are beautiful, they are artistic work. The largest of the 4 detectors. It's actually a few hundred meters away from here, just behind us. It's half the size of Notre Dame underground. I have been working on Atlas for almost 25 years, and every time I go down into the cavern, I think of and I can hear Debussy's beautiful prelude, La Cathédrale Engloutie, the sunken cathedral, where you can hear the sound of organ and bells coming from the depths of the sea, muffled by water. Let's listen to it for a minute in this beautiful performance by pianist Arturo Benedetti Michelangeli.
I'll just give you one tiny example about this Stradivarius. 1712 Cremona. It took about 100 years for 3 families living on one street in Cremona for these instruments to get to a golden period. And what happened with the Guarnerius, Amati, and Stradivarius families is that they hung their shingles on one street. Their daughters and sons were married, cousins were married to within each other's families. There were no secrets. There was plenty of competition and differences, but there were no secrets, which meant that they, multi-stakeholder, they actually all wanted to make better and better instruments. So I'd like to close with one thing.
Thank you so much for being with us. I leave you here on stage. You are going to play.
Well, I'm going to play one piece of music which actually refers a little bit to this glorious cathedral that you have built in underground. It is a piece that Arvo Pärt, an Estonian composer, struggled with in 1978. He was very disturbed because he wanted to write music that was more simple in a complex world so that he can actually describe complexity. And this piece called Spiegel im Spiegel, mirror in mirrors, when you put an object between 2 mirrors, you get infinity.
play?
Brahms Intermezzo.